So our two x-intercepts. So remember, that means that we have one at 4, 0, and negative 4, 0.
Why did you cross the 16?
I didn't? Oh, because you're multiplying by 0 squared, which is just 0. It goes away.
Why is that? Never mind.
Okay.
Why is 144 divided by 9 a square root?
No, it's just 16, and then you take the square root of both sides.
So are you always going to do that?
Well, for equations like this, yes. But sometimes your
Yeah,
equations
like
will
the
look different.
Always plus or minus.
Not, it depends on what your equation looks like. Not all of them are going to be like x squared, y squared. It could have different things. But you are always plugging in 0 for y.
We did this before, didn't we? Something like this.
Probably. We've done it more with linear equations. But now we're just throwing some other stuff in there. Okay, so then let's find our y-intercepts. Yeah. So now we're plugging in 0 for what? So the 9 times 0 squared goes away.
You're famous.
So you have 16y squared equals 144. And divide by 16. So y squared is 9. And then take the square root of both sides. And so y is plus or minus 3. So that means your y-intercepts would be 0, 3, and 0, negative 3.
So when you... So it's always plus or minus, right?
If you take the square root, yes.
So if you can't square root it, you just leave the square root there?
Yeah.
Do we have any of that?
I'm not sure. Maybe. Probably.
When it is going to ask for the x and y intercept, do you put the positives together and the negatives together? Like positive 4, 3, positive...
No, they stay with 0 because that's what the 0 is what makes them an intercept. Because they're crossing when...
so you don't put like
No.
them together?
No, so like your intercepts would be all of this separately.
And you have to graph that?
No.
Oh.
So we're just
Right, but this is how you can find out where it's crossing the x and y axis without having to graph it.
Oh, so it's like doing the job of a graph without
Yes.
the main graph. Okay.
Have we done something similar to this?
Yes.
Not good that said that.
24 days. Okay. All right. Yeah, we can go ahead and knock out symmetry today. Let's do that. Okay. So what is... Who remembers?
Like the same on both sides?
Right. So we can figure out if a graph is symmetric on the y-axis, right? Which would be like... So like y-axis symmetry would be something like this. It's the same on both sides of the y-axis. Okay? Then you have x-axis symmetry, right? We also have symmetry over like the origin. So like over the middle, which is kind of funky. Kind of like that. Like,
Still 10.1?
yes, still in 10.1.
Should I be drawing these down to you?
No,
What's it called?
symmetry.
Just symmetry.
So we can learn how to test for symmetry over the x-axis, y-axis, and origin. So for the x-axis, you are going to replace y with a negative y. And if the equation doesn't change, or if it stays the same, it is symmetric. Right, so we'll do one in a minute. So like, so then for the y-axis, you're going to replace x with negative x. And for the origin, you will replace both. And again, this last part stays the same. I'm cheating and using copy and paste.
Whoa.
That's smart, actually.
Right? It's one of those smarter, not harder. Yeah, that's exactly what I would do if I was you guys. Just draw arrows.
Technically, you just plagiarizing yourself.
Okay. So let's. All right. Do you guys need a second to get this down, or are you good?
Yeah.
Okay. Take my last sips of coffee.
Oh.
What do you make your
Since Savannah.
coffee at home?
Not recorded.
That's a smart voice.
I recorded it since you told me to record.
Okay.
Okay. So, ready for an example now?
Now it's up to the name.
Sorry, I write stuff.
You're fine.
I'm trying to write it down.
You're okay.
When it says stay the same,
None of the signs in your equation will change, is what it means.
Also,
If it's,
if you're like putting in a negative, doesn't it?
what if you square it?
Huh?
What if you square it? Negative times a negative is a positive, right?
Yeah.
Okay.
Oh, so you mean like
The-
the side, like your answer?
Yeah, like, it means that when you plug it in and like work through it,
Yeah.
your resulting equation looks the same as what you started with.
Okay.
So typically it's going to happen when you're squaring something. Or like anything to an even power, right, is going to negate that exponent.
I'm good.
Okay. So let's say our equation is y squared equals 4x. So for x-axis symmetry, we are replacing the y with a negative y. So when you square negative y, it's the same as, it's just positive y, right? So that stays as like y squared equals 4x. So it doesn't change. So we have x-axis symmetry.
Wait. Why does it go back to positive?
Because anything that's negative and squared is the same as the positive of it squared.
Oh, so if it's squared, then it's just.
Right.
Yeah.
It's gonna be the same every time.
If it's negative and squared, yes, because negative times a negative is always a positive.
but if we did the y-axis,
All right, we're getting there.
oh,
So then testing for y, oh no, my pen is dead. Please hold.
Who dies on yours?
Well, to be fair, I also haven't used it in like a week. So,
Yeah.
and I was more worried about charging my iPad this morning than my pen. So once it's charged, it lasts me for like a week.
I lost
It
like
ain't
5%
that
for
only
like a week.
I feel like my iPad's inconsistent. Sometimes it'll stay charged. When I don't need it, it'll stay charged 100% for
well, that's because you don't need it.
Right. Okay. So y-axis, we are replacing the x with a negative x. Right. So the y squared part will stay the same, 4, but we're plugging in a negative x. So when we kind of work through that, we get y squared equals negative 4x. Does that look different than this? Yes. So that means there is not y-axis symmetry. Does that make sense? Okay. So then when we do the origin, We are replacing both. So we are going to have negative y squared and negative x. We know that negative y squared is the same as positive y squared, and that still stays negative 4x, so there is not origin symmetry.
So it has to always be
No,
pause?
it has to match what you have at the beginning.
Okay.
So there's not gonna be origin symmetry if not both of the x and y axis symmetries are
Yes,
like.
typically yes.
Is it always gonna be, this, like, y squared equals 4?
No, you have to test it with all kinds of different equations.
Gotcha.
But you test it the same way.
Because I was like, what's the point? Never mind.
Yeah, the equation will change every time. Okay. So with that, on page 192, you can do problems 1 and 2.
Wait, we have a book?
1 and 2. Thanks.
Yes, right here. Look at me, I'm the new Isaac. I have 2%.
Isaac's
It's the man.
Okay, 1 and 2.